This video is going to cover mediation analysis, which is a neat way of decomposing the direct and indirect effects of an exposure on an outcome. Just jumping right into it. If we're looking at the relationship between smoking and lung cancer, an example of a mediator would be DNA damage, because that's how smoking leads to lung cancer. One of the ways is through the damage to DNA. Another thing to mention, I guess, is just that mediators are sometimes called intervening variables or intermediates. One thing to note about mediators is there's always more, basically. So before I had smoking to DNA damage to lung cancer, you could break it down further into smoking causing chronic inflammation, which leads to DNA damage, and even further into chronic inflammation causing reactive oxygen species, and DNA damage leading to oncogenesis. So you can always break it down into even more mediators. It's more a matter of finding which ones are easily measured and informative. So mediators can also represent measurable proxies. So if we're looking at smoking and COPD, let's just say that COPD is really difficult or expensive to measure, but there's an intermediate, like forced expiratory volume, that's really easy to measure. Then we could use forced expiratory volume as a proxy for COPD. Two potential issues with that are that maybe not everyone who gets COPD from smoking goes through that low FEV intermediate, and also maybe not everyone who develops FEV from smoking goes on to develop COPD. So it's imperfect, but there's a lot of times when using a mediator as a proxy for an outcome can be really valuable. So there's some problems with controlling for a mediator. So again, say we're interested in stress and BMI, and we think that the impact of stress on BMI is enacted through diet. We would create a model like this where the outcome's BMI. Let's say it's continuous, and we have our intercept, and we have stress here. We have the coefficient for stress, and this is just how stress is represented in the model. And this could be our model output. We'd have our intercept of a baseline BMI of, say, 18, and stress, let's say it's categorical, you're stressed or you aren't. Presence of stress leads to an average of increase of 2 BMI points. If we were to also control for diet, now stress has a different interpretation. It's stress when diet is held constant. So it's what is the effect of stress independent of diet. And as written, there's no effect of stress independent of diet, the way this diagram's written. So by doing that, you would eliminate the effect of our exposure of interest, which was stress. So controlling for diet in this case wouldn't make sense, because controlling for diet completely explains the effect of stress in this case. Mediation analysis becomes really useful and neat when in a scenario like this, where stress, in addition to having an effect through diet, also has a direct effect on BMI. And we're able to ask the question of how much of stress's influence on BMI is through diet and how much is direct. So this is the direct effect, and this would be the indirect effect through diet. And by trying to figure out this indirect effect, you're answering how much goes through diet, and by finding the direct effect, you're figuring out how much is independent of diet. And the total effect of stress combines the effect of these two paths, so total effect is direct plus indirect effect. So depending on the nature of your outcome, let's just say BMI is continuous, then with logistic regression, this relationship's simple, just like I said before. It's just additive. Total effect is indirect plus direct effects, but it gets a little more complicated with logistic regression, like if we had high BMI versus low BMI, where total effect is now exponentiated indirect effect plus direct effect, which if we were to convert those to odds ratios, it would be multiplying the odds ratios, where this would be adding the coefficients of a linear regression. Logistic is a multiplicative scale, so you'd have to multiply these odds ratios. So mediation analysis is what we call it when we are decomposing the effect of stress into its direct and indirect effect. There's some assumptions that we need to make sure of before we can look into this, though. The first is that there's no uncontrolled confounding of the exposure and outcome. The second is that there's no uncontrolled confounding of the mediator and the outcome, and no uncontrolled confounding of the exposure and the mediator. So basically no confounding is allowed. And yeah, so for this first example, I'm going to do linear regression, and there's two major methods for mediation analysis. This first one I'm going to talk about is the difference method. So some assumptions for this example are BMI is going to be continuous, stress is going to be categorical, so you're stressed or you aren't, and diet's going to be categorical, so a healthy diet or an unhealthy diet. So the first thing we do is, if we do a model that just has BMI and stress as a predictor, this is going to be the total effect of stress. So this coefficient that we get 7, that represents both the combination of stress's direct and indirect effect. So being stressed in this case resulted in a 7-point increase in BMI. The direct effect is, on the other hand, we can do by adding diet, because when we add diet to this model, basically what we're doing is now the coefficient for stress is the effect of stress when everything else in the model is held constant, and diet's in that model. So now this path of diet is now eliminated essentially in our estimate of the effect of stress on BMI. So we have the direct effect of stress, and let's say that comes out to 2. And yeah, so independent of diet, stress causes a 2-point increase in BMI. So now we can find the total effect, so total effect is the direct effect plus indirect, and we have total and direct. We can solve for indirect just by rearranging this. So total minus direct, 7 minus 2, we have an indirect effect of 5. So basically what we learned from this is that most of the effect of stress on BMI is actually mediated through diet. Or 5 points is what's happening through diet, while only 2 is the direct effect of stress. Now, still on the difference method, but now just to show a logistic example, stress and diet are still categorical, but now BMI is also categorical, so high versus low. We go through the same basic steps. We start by finding the total effect. Total effect, so our model looks the same. Just inputting stress into the model, except now what is output is a coefficient that isn't readily interpretable. You'd have to exponentiate that to get an odds ratio, but let's just, okay, I did it right away. So exponentiated, that's an odds ratio of 2.5. So those that are stressed are 2.5 times more likely to be identified as high BMI. So now we can find the direct effect, the same as before, by having a model that has both stress and diet in there. So if we find that, this would have a coefficient in reality, but I'm just going to not include it just because it's irrelevant to the difference method. If it comes out to 0.4 and exponentiated, that's 1.5. So now, the same way as before, we found the indirect method by having the total minus the direct. We can do that, but remember we're on a multiplicative scale, so to get that onto an additive scale, you need to exponentiate it. So we take these coefficients. We have 0.92 for the total effect minus 0.4 for the direct, and that comes out to an indirect effect of 1.68. Yeah, so now we've decomposed the total effect into its direct and indirect. So the direct and indirect effect of stress is pretty similar, but you can see that a little bit more of the total effect of stress is explained by its path through diet. And we can verify this total effect was 2.5 that we found through regression. We can verify by looking at, since we know that the total effect should be the odds ratio of the indirect, because when you combine with linear regression, when you combine two paths, you just add them. But with logistic regression, it's on a multiplicative scale, so to combine the direct and indirect effects, you multiply these odds ratios, and that comes out to 2.5, so we know it worked. The product method I don't really like, but this wouldn't be a complete video if I didn't talk about it. I just find the difference method makes more sense to me conceptually, but I'm just going to talk about the product method quick. So you start by finding we're doing logistic regression still, the same numbers. So we find the direct effect first by putting stress and diet into the model. And now the coefficient of diet is all of a sudden relevant, and we'll talk about why. So we get a coefficient of 0.4 for stress and a coefficient of 0.87 for diet. So I'm not going to convert them to odds ratios yet because there's still some work to be done with them in this form. So now we've found two of the three stages of this relationship that we're interested in. The only one we don't have is the impact of stress on diet. So if we do that regression, even though BMI is our outcome of interest, if we're just interested in this relationship to complete the picture, we can have diet as the outcome and stress as the exposure. So if we do that regression and get 0.6 as the coefficient, now we have everything we need to basically figure out to figure out the indirect effect and direct effect. And so the indirect effect is the product of these two steps on the indirect path. So stress to diet has a coefficient of 0.6 and diet to BMI has a coefficient of 0.87. To combine those effects, you would exponentiate and multiply them. And that comes out to 1.69, which represents this indirect effect. Just to get 0.4 onto an odds ratio scale, we exponentiate it, so 0.5. And to get the total odds ratio, like we did before, we can just multiply the direct and indirect ones, and we get 2.5 again. So mediation analysis is pretty neat, and hopefully some of that made sense. I believe there might be situations where the product method is favorable, but since the difference method seems to apply to both logistic and linear regression, I don't see a reason to mess with the product method.